Hello students, welcome to Java programming course. Currently we are discussing about the chapter called Packages in Java Standard Edition 8. And here from unit 4, this is the first chapter and currently we are at video 6. The first topic is Java.util classes and interfaces. Next one of the class includes this package formatter class. And next one, random class. Coming to the first one, Java.util classes and interfaces. So here this Java.util has many type of classes that generate pseudo random numbers. That it means supports the random values generation in many type of real-time computer science and application. This random number generation is one of the requirement when working with the solutions or generating solutions to the real-time applications. And also next one is a manage date and time. So to manage date and time, this util package also helps the programmers to manage these things in your programs or in real-time applications like networking, like most probably. And observe events. That it means you can write a module of code to observe what events are happening with your computer system or in a particular situation, and we'll see this event handling in the as a chapter in the upcoming chapters of our curriculum. And manipulate sets of bits and tokenize strings. Tokenizing means dividing the dividing the strings into tokens. And handle formatted data and there are many type of classes are specifically designed inbuilt classes in this package to support these type of operations at real time. And we are going to discuss two of these classes in this video today, that it is random class and formatted class. And coming to the Java.util package also contains one of the Java's most powerful subsystems, nothing but a collections framework. So in Java, the features added for some real-time applications to work with data organization, specifically taking support for data organization into any real-time application, nothing but a structure for data. We are going to organize the data for our programs in Java language. This collection framework is a sophisticated hierarchy of interfaces and classes. So with the help of inheritance, they created some hierarchy of these interfaces and classes for giving this collections framework in Java programs that provides the state of art technology for managing group of objects. So here the group of objects where you are organizing some set of group of classes are working as a framework designing that to make these collections into as a one unit to help you take that different classes, methods and interfaces into your importing into your classes or programs. And this util package contains a wide array of functionalities. It's quite large, very not limited. There are many type of specialized classes and interfaces designed and making a part of this util package. So generally in our computer complete reference book, this util package contain completely organized in two units, two chapters, right? Two parts, part one and part two. So here part one discussed about the completion collection frameworks that it be part of this util package. And later part two of this util package organizes about the interfaces and the classes of, maintained in this util package. And here it is the list of top level classes, top level some a list of classes we given for an important classes here in this from this package. So all these type of classes are specifically maintained in this Java.util package. And we know some of these classes already we used in our programs earlier, that it is scanner class. And you know that scanner class is used to give the user input to the programs through keyboard, right? And we already discussed about the scanner class, and we are going to discuss one more formatter class today and also random class today. And tomorrow we're going to discuss some remaining rest of the topics from this unit. Going to discuss some more classes with respect to time and date. Okay, there are time and date, like there are many calendar organization there, collections there, currency about it, array, and these are the supportive for data structure organization for data structure point of view. Some of the topics collections are also available, right? And these are the interfaces defined in this util package. Take type enumeration interfaces for creating enumerations. In the previous video, we learned how to create enumeration with some constant values like that. And iterator interface is also there for providing you to the iterative processes in your programs by creating instance to this class interfaces. Mapping is also advanced and features added in Java in this util package to organize with this map data like that, and sets, random access, queue, list, right? Next one, collections overview. And first we discuss about this collection frameworks given in this Java.util package. Later we come on to this classes and interface. So coming to the first one here, Java collections framework standardizes the way in which group of objects are handled by your programs. So I told you that some set of collection classes or interfaces specifically organizing in this framework to help you to design research applications with a simple coding way, right? The collection frameworks were designed to meet several goals. The first one is the framework had to be high performance. Why this framework we making to setting these classes to import into your programs to work with the real-time data organization point of view, or maybe in some of the real-time application designing operations or many methods that are making into a one framework to give an efficient and high performance outcomes, right? So that is the first and most important goal of this collections framework, nothing but giving to high performance for your programs. And the implementations for the fundamental collections of, you know, that dynamic arrays, linked list, trees, hash tables are highly efficient. So when we implement these type of collection frameworks for your programs, then it automatically gives you the efficiency as well as high performance, right? Second one is the second goal of this having collections framework in Java is the framework had to allow different types of collections to work in a similar manner. So we can make some different types of collections or maybe different types of with different methods operations. We also use all those in work in a similar manner and with a high degree of interoperability. Interoperability means even though they are different in nature, but they can having some working in similar manner, working in similar way. That is the second goal. Third one is extending and or adopting a collection had to be easy. But it means once you make a collection framework by including some different classes and interfaces for making use of those methods defined in those collection classes and like. In this framework, you can extend this one. Whenever you need to add some more collections into this framework, yes, it is to be extended. or you are going to adopt any type of maybe properties from other, that should be easy to this framework. That is the third one. So based on these three type of goals to achieve maintaining the collection framework for your programs to make efficiency and to make your programs high performance, and it is easy to extend or adopt your framework collection. In addition to this collection frameworks, the algorithms are another important part of this collection mechanism. So algorithms for your real-time applications generally, when we go for a real-time application to provide a solution to many problems in real time, we need some set of computer science algorithms. So when you are giving solution to those problems, so writing algorithm or designing algorithm for the based on the techniques we are going to use to solve the real-time cases. So that's why in this Java, it provides you some set of algorithms. These algorithm operates on collections and are defined as the static methods within the collections classes. Collections, right? So all these algorithms are already designed and built in and make them as a static methods in the collections class. Then you can import those algorithms in your program to give the solutions to the real-time applications at real time. So it makes you to reusability of the code that are already built in as an algorithms. For example, you are going to apply a stack. So some stack algorithm is already implemented and that is then making as a method of the collections class. Then you can import that one. I'm just giving an example for your better understanding. Okay. Next one. So this is about something about collection framework. Coming to the classes and interfaces, when we go to discuss one important class that are already covered in earlier topics, that is scanner class. It is used to get user input and it is found in the Java.util package. And we know this one. To use the scanner class, create an object of the class and use any of the variable methods found in the scanner class documentation. What it means here, we know the scanner class process. So first we have to create an object of the scanner class, then allocate memory with the constructor of the scanner class by making that as a connect to the system.in input stream. System.in. Why? Because this to be take input from the keyboard. Right. Next one is using that scanner object to call the methods that are defined in the scanner class. So next thing like that, maybe next line, like different type of methods are available in scanner class. And using that scanner object, we can import those methods into our programs. Right. So to use the scanner class, create an object of the class and use any of the available methods found in the scanner class documentation. Next one. In our example, now we are taking one simple example. We will use this next line method. We already used the next int method for reading integer values from the keyboard as a user input to the program. The same way here we just taken another method for your convenience. Next line method which is used to read strings, So this is one example here. Import java.util.scanner, importing scanner class, and my class inside of main class main method. I'm creating first object of this scanner class using the scanner constructor connecting to this input stream, system input stream, and I'm just giving one input statement like enter username. String username. Username is now is a string object, right? String followed by username equal to my object dot next line. Here it is. Once you understand this process, I'm using this scanner class object to invoke this method for reading the string from the keyboard as an user input, right? So here it is. This one is user input. I'm using this scanner class object, my object dot. I'm invoking this next line method of this scanner class to read a string from the keyboard and store that into username. That username is a string object. So I'm displaying that username object to of the value. So it automatically gives you the whatever the name you entered from the keyboard as an user input, and it gives the same for your user output. Got it? This type of way we already discussed the given input value from the keyboard as an integer value, right? I hope you understand clearly about this. It is one of the classes scanner. And these are the some list of methods available in this util scanner class. So this next boolean is a method to read a boolean value from the user. Byte, double, float, int. Next line is used to read a string value, not next string. Don't be made confused here. All these data types are using the same next string, next float, next double, next byte, next boolean. But here, next line is the method to read a string value from the user, right? The next one is next long, long value, next short, short value. Got it? Next one. So these are some basic and some of the important key points to be discussed about this Java.util class and interfaces. Next, go to the another type of class of this util package is formatter class. So it provides format conversions, right? Why we need conversions of these formats specifically at the output? And this concept is already familiar to you in the languages subjects like C and C++, right? So these format conversions let you to display numbers, strings, time, and date in virtually any format you like. So at the output, some of the times you may want to display the numbers with spaces, some with tab spaces, or with line by line, or it may be a steps line. So whatever you type of conversion you need to with these type number strings and time and date, and it is allow you to format your data after processing. So that's why in Java it is taken care about special care, and one built-in class is defined for this. In C++ and C, you just make use of some specifiers and escape sequences for doing your format of data, but here it is specifically designed one class with some methods, right? So it operates in a manner similar to C++ printf function, where you use these escape sequences, tabs, text line, spaces, quotations like that one, right? Which means that you are familiar with this topic, right? Next one, the formatter class contains one type of some type of special constructors for creating an object of this formatter class. And we know this point well. In Java.util packages, some built-in classes are already available. To access the operations or methods defined by those classes, we need to create an object, or we need to create an instance of those classes for making use of the methods defined in the package classes or interfaces, right? So here it is the concept called. So to create an object of such classes defined in the packages, we need constructors right now, but here it is formatter constructor. Why? Because this class having some set of constructors for different purposes, right? So before you can use formatter class to format output, you must create a formatter object, right? Every time we must create an object of built-in classes to make use of those methods. In general, formatter works by converting the binary form of data used by a program into formatted text. So whatever the things you are after processing data, this formatter class gets those data, and it works by converting when it works for your output at console. So you want to present the data in your specified format. So this formatter class do that work by converting the binary form data collected from the processing. Then it convert that into a formatted text. So remember this point. So to make these type of functionalities with this construct formatter class, we need some set of constructors specifically defined for different type of actions. So the formatter class defines many constructors which enables to construct a formatter in a variety of ways. Suppose take this one formatter and normal formatter constructor, let's like a default constructor type, and it is appendable buffer. But it means already you have some set of buffer locations to hold your data to present formatted as you specified at output. It also appendable buffer means it can add some extra buffers too, right? So like this way, string file name. Sometimes this formatter may throw an exceptions, and the exceptions concept we go to discuss in the we'll go to discuss these topics in the upcoming chapters. Nothing but now the next chapter in this unit 4, exception handling. So based on this type of exceptions, it supports you to intimate you this type of exceptions will generate when you set the data or format the data by creating instance like this, setting file names, string character set like that. Okay. And next one, these are the some set of methods defined in the formatter class of this util package. Here it is close. Void close is a method. It invokes formatter s. This causes any resources used by object to be released. After the formatter has been closed, it cannot be reused. So once the formatter is invoked by this method, it can be used to cause any resources used by the object to be released. Once it is closed, it cannot be reused. Right? So when you're trying to use, it gives one type of error called formatter closed exception. Exception means one-time error. That already closed. Formatter is already closed. You are not supposed to use it. Right? Next, flush is a one of the function we already discussed. I mean, you may use in C and C++ programming. Right? This flush is nothing but it's a buffer. It's a buffer, and specifically here we talk about that as a format buffer. This causes any output currently in the buffer to be written to the destination, right? Supplies mostly type to a file. In files also, we use this flushing C and C++ for arrays to initialize or memory refresh like that. The same way here also format for string and another type of object arguments and local values arguments, IO exception. These are the different methods. If you observe here, toString is one of the method. Again, we got this method in this formatter class. It returns a string containing the formatted output. So we'll see one simple example here. So formatter is a class followed by object of this formatter class, and I have used this default constructor, only default constructor, right? This one, default constructor for creating this one. And I'm making this, and I'm using one of the format method by using this format object dot format method, and here I'm giving just one string value with this some specifications, percentage s, d, and f. Here another comma, another string value, comma, integer value, and floating point value. This sequence creates a formatter that contains the following string. So it contains the statement like Formatting with Java is easy. Formatting this, I will show you here. Yes. Formatting as it is okay. Percentage S here, it means it taking the first parameter value. Here it is, first letter value. After this comma, this is the one, and it places here. And is easy is no more. And this D integer value can be this here, and floating point value. So this way I want to get my data formatted like this. Okay. The same way I'm using this formatting method, format method, using this formatter object. I'm making this data as my own format at output. So next one, random class. So it is also one of the built-in class available in this Java.util package. And this class is a generator of pseudo random numbers. We can generate random numbers. I told you that this random generation, random number generation is the most most important requirement in some of the applications, right? These are called pseudo random numbers because they are simply uniformly distributed sequences. This random number generation, nothing but a sequence of distribution, and I will tell you with the example. This random defines the following constructors. Random defines the following constructors. Random constructor and random with one argument. I am considering this argument as a seed. Seed nothing but a where the starting point to generate this random sequence. And the first version, here it is the first version constructor. The first version creates a number generator that uses a reasonably unique seed. Unique seed means that the generation of number is unique. Once you started calling this random class for invoking the methods defined in it like that, when we create an object of this one, then that generates the random numbers in a unique format, right? The second one is the second one. Second form allows you to specify a seed value manually. A seed value manually, right? So I will go to take this. The public methods defined by the random class. There are there's some set of methods are defined here. Okay, but here it is. There are 7 types of random numbers that you can extract from the random object. Once you create a random object for this random class, it generates 7 types of random numbers, right? So for maybe Boolean values, right? Maybe next byte values, double, float, Gaussian, integer, next int, okay, next long. So these are different types of random numbers can be generated or extracted from a random object of the random class. I'm coming to this simple example. See here, import java.util.star, or simply you can write random here instead of this star asterisk symbol. And coming to the main class called demo, inside of this main method, and creating an object of this random class. Here it is, small r is my object, and I'm using this object to call one of the method defined in the random class. So here I'm just using this next int method. What this method doing here? This method returns next int random number, next integer random number, right? Next integer random number. So it is based on You know that random number range of generation, random number, integer number range. So in Java, it is 4 bytes of data of size required for integer value. So 2 power 32. So nothing but it having a wide range of number generation, right? So among them, one random number will automatically generated and extracted from this range by this random object of this random class. So that it means what is output? Any random number from this input type like int type range, right? So I will show you this practically. So coming to the demo program, the same, the file name is saved as demo, and I written same here, and go to command prompt. So what is the file name here? Java C demo.java. Compile it. As it is successfully compiled, you go for run Java space demo. As it is generated one random value at this time, right? When I'm trying to execute again, it generates another random number from that sequence. So all these numbers are the value of the integer range of based on the size specified or given in this Java for integer, that is right. Okay. Again, it's generating. Yes, clear. Everything is okay right now.